Hi everyone, wishing you a very good morning. I hope all of you are doing fine. Good morning, Deepak. Good morning, everyone. Good morning, Teja. How are you doing? Okay. Good morning, Yashwant. I hope everyone is safe, healthy, and fine. Anjali, good morning. So, let us now start today's class. Good morning, Karthik. Again, as I always start, good morning, Sai. Keep your mobile phones off. And if you have to say anything, send it at the ID with the name of Stick. That is the ID where if you want to chat, you send your messages there. Now, before going on to today's class, Vahini, good morning. Someone is sending me messages over here. Bipin, do not send me messages here, beta, on this ID. Send the message on the other ID. I won't be able to respond on the ID through which I am taking class. So that screen is filled. Send your message on the other ID. Now we had discussed the graphs of motion in one dimension. We had discussed the position time graph only. Good morning. And we had seen the different types of position time graph. Correct? Now we'll start with some questions so that we have an understanding of what sort of questions you can expect in exams. So we'll start with the first question. I hope I asked you to do questions from the notes. I don't know how many of you have done it, but still it's my job to tell you to do some questions. And here is the first question that we are supposed to do, and that is problem number 21. Good morning, Sri. Problem number 21. Can you see this problem, beta, everyone? Problem number 21. It is again from your notes. And the problem is pretty simple. Which of the following graphs represents uniform motion? When I talk about uniform motion, it definitely means motion with uniform velocity. And Karthik has come up with an answer. And the answer is definitely, what is the answer, everyone? Which graph represents uniform motion? Yes, Shreya. Option number A. That is the graph that represents uniform motion. Please don't write on the screen. Please don't do it on the screen. I would be throwing you out of the room if anyone does it. If you think that I don't see who has done it, I know who has done it because the name shows on the screen. So if anyone plays around with the screen, I'll get him thrown out of the room. Okay, yes, Bipin, what is your doubt? What is your doubt, Bipin? Ask me. Yes, Bipin, what is your doubt? Ask me. Straight line motion. Motion is a straight line. We'll come to your doubts, don't worry. On mic, you want to speak? Okay, ask your doubt.
Sir, what is motion?
What is? What is what? I didn't get your doubt. You can write it. I didn't get you. I'm sorry, beta. I didn't get you. So I guess we have done with question number 21. We are done with question number 21. Let us move and solve question number 24. That is the question that we need to solve. Question number 24. Question number 24. What is question number 24? The diagram shows the displacement time graph for a particle moving in a straight line. So this diagram shows the displacement time graph for a particle moving in a straight line. We have to find the average velocity from 0 to 5 seconds. What is the average velocity from 0 to 5 seconds? Please note down the question. I'll have to restart your notes because someone has made a ugly mark on this, which is so stupid, so stupid, so stupid. So I'll switch off this and I will again start. Please note down the question. I will again start the note because else it will not get erased from the thing. And someone has done a stupidity. I don't know how stupid student can get. So please note down the question. From 0 to 20, it is going in a straight line, the particle, and then from 20 to minus 10, it is going down. Just see this, and I'll come back and I'll again restart this one. Okay. So note down the question and we'll be solving the question now. Okay, I hope we are back. I hope we are back. Question number 24. We are solving. Bipin, what is your doubt? Please type your doubt, beta, in the thing. I was not able to hear you. What is your doubt? I did not get you. Ask your doubt again. Ask.
Sir,
Yes.
what is the problem 24, sir?
Problem 21st is already gone, beta. We are now on problem number 24. Let us concentrate on problem number 24 now. 21 is already gone. 21 problem was this one. Which of the following graphs represents uniform motion? We have already done this question. The straight line graph represents uniform velocity, and that is the graph for uniform motion. Okay, beta? Clear? That was question number 21. These questions are from your notes. The notes are in your app. Please go through them. If you still have doubt, you can come back to me. Okay, Bipin, am I clear? Question number 24. Let us concentrate on question number 24 now. This is the graph given for question number 24, and we are supposed to find out the average velocity from 0 to 5 seconds. I hope everyone can see this. Please do not do any marking on the screen. I have disabled it, but still, if someone makes a mark, I'll throw him out. Okay, I got an answer as well. Great, great, great. I was so angry with someone who has done this. I'm sorry, beta. It just takes off my mind from the class. Don't do such things. I don't appreciate them at all. Okay, someone has given me an answer. Who was that? I missed it. Yes, Karthik. The answer is -2 meter per second. Wow, great answer, Karthik. -2 meter per second. How did you get the answer, Karthik? Would you like to tell me? Would you like to tell everyone how did you get your answer? I'm asking you to unmute. So tell me how you got the answer so that every one of us can listen to you. Karthik, over to you.
Sir, first
Yes, beta.
the object is moving upward, sir. +20. Then
Sorry,
object
beta.
is coming down.
Sorry, beta. I can't hear you. Please, can you bring it closer and then speak? Okay, maybe I lost Karthik. I'm sorry. I think you have got the average velocity is total displacement upon total time. That is what Deepak says. Just Deepak, that is the correct answer. Total displacement upon total time. The only thing is you have to find out the total displacement from where to where. From 0 to 5 seconds, you are supposed to find out the total displacement. Yes, Karthik. First, the particle do not go up and down, beta. This is particle is moving on x-axis, so it is not moving up and down. It is moving left and right. So when it is positive, it is moving towards right. When it is behind 0, it is going towards left. Am I clear? Am I clear? Everyone understands this? How is the particle moving? How is the particle moving? From 0, as you can see here, from 0 to 2 seconds, from 0 to 2 seconds, it is moving from origin to 20. Origin to 20 in the right hand direction plus x-axis. From 0 to 2 seconds, it is moving from origin to 20. From 2 seconds to 4 seconds, it is moving back from 20 to 0. So it is moving leftwards. From 4 to 5 seconds, it is moving behind 0. Am I clear? Everyone understands the motion? Can I have raised hands so that I understand that, sir, we understand this? We have understood the motion. 0 to 2, it has moved in the positive x-axis from 0 to 20. Then from 2 to 4 seconds, it has moved from 20 to 0. And from 4 to 5, it has moved from 0 to -10. Only 12 raised hands. Where are the other people? Let me call out here some names. For someone, okay, great, great. Everyone is participating. Great, great. What about Venu Kumar? What about Adit? What about Charita, Santosh, Sai Teja? I did not find you. Hanak, where are you? Jagdeep, Kevin, I don't see you. Padmakan, Sai, Sana, Krishna, Shiv Prasad, Spidey, you're again roaming around. Surendra, where are you, everyone? Okay, great. Now I have around 30, around 35 and 4 or 5, 6, so around 40. That's good enough. So now we have to find average velocity. And as someone told me, average velocity is total displacement. As you can see over here, it is total displacement divided by total time. So I have to find total displacement. How will I find total displacement is the only question now. How will I find total displacement is the only question now. So what do I do? What do I do? I look at its position. Let me write the question number. First. This is question number 24. Let me write the position x. The position at time t is equal to 0. So the position is x is equal to 0 at t is equal to 0. Do we agree on this, everyone? At time t is equal to 0, the particle is at x is equal to 0. You can see it from the graph. Then we find the position at t is equal to 5 seconds. What is the position at t is equal to 5 seconds? Look at the graph. The position at t is equal to 5 seconds is x is equal to -10. X is equal to -10 is the position at t is equal to 5 seconds. So what is the total displacement? This is the final position. This is the final position that we have. Everyone, please look at this. This is the final position. This gentleman is the initial position. Final position minus initial position will give me displacement. So my displacement will be x final minus x initial. That will be my displacement. So displacement is x final is minus 10 minus 0. So that becomes minus 10. Minus 10 meters is my displacement. Minus is indicating. What is minus indicating, anyone? What does minus indicate in this? What does minus indicate here? What does minus indicate here? Minus is important. It indicates the direction, Santosh. Yes. That means the particle has actually moved in the left direction. The overall movement is in the left, not downward, Vahini, not downward. Please look at the diagram. Please look at the diagram. Please look at the diagram. Not downward, not downward, Vahini. Look at the diagram between T and X. The graph is drawn, so it is on the x-axis. Don't say downward, it is leftwards because it is x-axis. My x-axis is always horizontal. So minus 10 meter is my displacement, total displacement. I have to find V average. I have to find V average. V average is total displacement divided by total time. Total displacement is minus 10. Total time is 5 seconds. So my answer is minus 2 meters per second. That is my final answer. Do we understand this, everyone? Can I have some show of strength with some raised hands? Yes, sir, we understand this. We understand this. No problems with this one, sir. No problems with this one. We understand this. Great, great, Deepak. 22 raised hands. Great. Now, I will take you to a question from the DPP. Here comes the question on your screens. Now, where is this question? Where is this question? The question is here. The question is here. Here it comes on the screen. Yep. Graph related questions. Graph related question. Question number E1. This is from your DPP. Question number E1 from your DPP. What does the question say? What does the question say? The displacement time graph for two particles A and B are straight lines. Straight lines. Inclined at an angle of 30 degree and 60 degree with the time axis. 30 degree and 60 degree with the time axis. What is the ratio of velocity? This question has come very recently in JEE Mains 2020. Second or third, second attempt, I mean second session. So JEE Mains, second session question, this is 2020. Displacement time graph, it should not be displacement time graph, it could be position time graph. As I told you, sometimes they will write it displacement time graph. Don't be confused. It's position time graph. So position time graph for two particles A and B are straight lines. One is at an angle of 30 degrees, the other is at an angle of 60 degrees. What is the ratio of velocities? Your time starts now. Your time starts now. Anyone with an answer? Your time starts now. That is why it is always good to understand the concept. Once you understand the concept, someone is sending me, Bipin, I think you have cleared your doubt. Sai Tarun, please send your message on the other ID, but I won't be able to check this ID. Please understand this. So the displacement time graph or the position time graph, Manasa has come up with an answer. Manasa says 1:2. How did you get 1:2 answer? 1:2. How did you get it? Answer is not important. Important is Goli also gets 1:2. I don't know how you are getting. Remember, we are not playing Kaun Banega Crorepati. Who wants to be a millionaire? We are not playing that. We cannot guess. You should understand the logic behind it. What is the logic behind it? I am more keen on understanding the logic rather than getting the answer. So your logic should be correct. Anyone can give me how did I get or how anyone is getting 1:2. I don't think 1:2 would be the answer. I don't think 1:2 would be the answer. Anyone? Question number E1. We are on question number E1 from your DPP. Anyone with an answer? Anyone with a different answer? I already have an answer. E1. Question number E1. No one? So here I draw the graph. This is T axis, this is X axis. So I have got two particles. Let me call this particle 1 by the red line. Let me draw it again. The graph is inclined at an angle of 30 degree for the particle A. The second one, let me make it B, and it is inclined at an angle of 60 degrees. What is the ratio of their velocities? What is the ratio of their velocities? Anyone? Now remember, what was velocity? Velocity was the slope of this graph. Slope of position time graph was velocity. Do we remember? Slope 1:3. Yes, Karthik, that might be the correct answer. Slope of this graph. Slope of position time graph. Now the slope of this graph is given by this angle. But we do not divide angle by angle. We do not divide angle by angle. Yes, Karthik, you're giving me the right answer. We do not divide angle by angle. We find out the tan of this angle. So tan of 30 degree will give me the velocity of body A. Tan of 30 degree will give me, yes, Santosh, you're also correct, I think. Shreya, you're also correct, I think. Tan of 30 degree will give me the velocity of A. How will I get the velocity of B then? How will I get the velocity of B then? Anyone tell me now on the same logic. How will I get the velocity of B then? I'll get the velocity of B with tan of 60 degrees. With tan of 60 degrees. Yes, Reddy, you are correct. Now I have to find the ratio of velocity of A by velocity of B. So this would be nothing but tan of A divided by tan of B, which is nothing but tan of 30 divided by tan of 60. And from here I will leave this question because you know what is tan of 30. Tan of 30, Reddy, is 1 by root 3, and tan of 60 is root 3. So 1 by root 3 divided by root 3, I think the answer would be 1 by 3. 1:3. That should be your answer. Am I clear with everyone? Am I clear with everyone? Do we understand this, everyone? Do we understand this, everyone? Can I have some show of strength? Raise your hands with a show of strength. That we have understood this question, how we have done this. We have found out the ratio of velocities from nothing but a graph. We had the inclination, we had the angle, tan of one angle divided by tan of the other angle, and we had our answers with us. Now, please all of you lower hands, anyone who have not understood, anyone who has a doubt in this, now please raise hands. I have 5 raised hands on that. Anjali, Sri, Tejasvi. Okay, these were the raised hands from the previous thing, I guess. Does anyone have any doubt? Please raise your hands. I am waiting for you. I am waiting for your doubts. Is there any doubt with anyone? Clear, sir. Clear, sir. Okay. 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 Now, I'll give you one question, and this question will have all types of questions that could be made in this particular displacement or position time graph. So I'll make a question, and 1 or 2 parts of this question have already come in exam. So I'll let you know that part as well. So let us now move on to a question that I have created for you. The values may be different. The actual question that appeared in the exam in JEE mains 2019, I guess. The values may be different, but the concept remains same. So we concentrate on the concept part of it and let go the value part. Okay, so this is an X-tree graph that I have drawn for a particle, and the X-tree graph looks like this. Tung 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 tung, tung 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 tung, tung 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 tung. And like this. Okay, so here the time is 0. Here the time is 2 seconds. Here the time is 4 seconds. Here the time is, here the time is 5 seconds. Here the time is 6 seconds. Here the position is plus 10 meters. Here the time is 7 seconds and the position is -5. So the particle is moving, as you can see, from O to A, then A to B, B to C, then D, then E. Is the question clear? Is the diagram clear to everyone? Have you drawn this diagram? All the times are given, all the x coordinates are given, that means the time axis is given and the y axis is also given to you. Now I will start with question, and question number 1 is, let me write question number 1. Question number 1 is, what is V average from 0 O to A? What is the average velocity from O to A? Your time starts now. What is the average velocity from O to A? Look at the graph, get me the answer, and we are done. What is the average velocity from O to A? I'm waiting for your answer. What is the average velocity from O to A? Reddy has won the contest this time. The average velocity from O to A, he has given me an answer. I won't let you know the answer. I'm waiting for Spidey has come. Welcome, Spidey. I was waiting for you. Karthik has given me an answer. Karthik, your sign is wrong. It's not minus, not negative. Goli has given me answer 5 meter per second. That is the correct answer. 5 meter per second is the correct answer. And how did we get that answer? 5 meter per second. Anyone? Total displacement. The particle is at O. This is the initial position. The position is 0. A is the final position. The position is 10. Final minus initial position is answer, and I'm happy about it. Only 11 participants have got the answer. There must be something wrong somewhere. Let me Sai, Sana, Shreya. Shreya has got the answer. Triveni, Jashwant, Srilata, Josna, Surendra. Okay, we got the answer. Now, one question more. Same diagram, we cover everything. And this is the question that came in your JEE mains. Is the velocity from O to A constant or variable? Is the velocity from O to A, 0 to A, O to A, so O origin, O to A constant or variable? Yes, Hannah, the answer is in the velocity is not the question. And let me velocity of the question. What is the velocity? It would be somewhere here in between. What is the velocity? Can anyone give me the velocity at 1 second? What is the straight line graph? And Goli has an answer 5 meter. Meter cannot be a velocity. Ready? No, Siddharth, Spidey, you're wrong. Velocity is constant. Yes, Deepak, velocity does not change. So whatever is your average velocity, that will be your instantaneous velocity at all points. Am I getting clear? Am I getting clear? No, some people are giving me answer 5 meter per second. Don't say 5 meter per second. You are missing the essence of vector, beta. You are killing physics. Don't kill physics. Don't kill physics. Don't say 5 meter per second. What you got to say is plus 5 meter per second. It's a vector, beta. It's a vector. We have to give it direction. If you don't give the vector its direction, the entire essence of the vector is lost. You are not talking about its direction. Everything gets lost. Am I clear? Plus 5 meter per second. Raise of hand, show of strength. Lot of energy has gone in that stupid act. It's thirsty. Okay. Okay. Great. That was the question from JEE Mains, I think 2019, some attempt. Forget about it. Now, the next question. What is the average velocity? I will write it here. What is the average velocity from A to B? What is the average velocity from A to B? Shoot your answers. Shoot your answers. What is the average velocity from A to B? What is the average velocity from A to B? 0 meter per second. The particle is going though, but and the final position. The final position is C, which is 0. Final position is 0 minus initial velocity divided by time is 1 second. So it becomes okay. Question number 4 or question number the 8 maybe. What is the average velocity from 7 seconds? And the answer is from Karthik. Well done, Karthik. Well done, Goli. Correct answer, yes. Hannah from Shreya. Some classes expression plus 5 is not the point is at minus 5. Minus 5 is point E. Divided by 2 times. This is average velocity, and that is people got the answer, got more response. Let me ask the answer then. Let me ask the answer. Surendranath, Tarun, Sendarun, Harita, Lindy, Shah, Reddy, Rahul, Padma, Ankita, where you guys data? Tini, Manasa, Vinu, we are in the same final position is your Dakshan. Dakshan, what is the average velocity? What is the entire means of 7? Counting for others. 0 to 7 that I can again ask you to raise them. Okay. My better to write enough, better to write in fraction. 5 by 7 is correct, Konda. You are correct. So just look at what is the final position. Yes, Santosh. Yes, Karthik. Yes, Shreya. Shreya, you are missing the unit. Okay, I understand that you understand the unit. Sri, you are also missing the unit. I understand that you understand the unit. Final position is position E at time 7 seconds. And the position is, I am highlighting it, minus 5. So the final position is minus 5. The initial position beta at time t is equal to 0 is your origin. So final position is minus 5. Minus initial position is 0. Minus 5 minus 0 divided by the total time. Total time is definitely 7 seconds. So this becomes minus 5 by 7 meters per second. Am I clear with the concept? Do we understand this? How we have done this? We have done almost every question that was possible in this category with just one simple question, and we are done. Anyone still has a doubt? I'll give you 2 minutes. 1 minute to think about it. Think about the entire thing. Let me have a quick recap. We are done position time graph and distance time graph. As you can see, hardly any question comes on distance time graph. The slope of position time graph gives us velocity. It can be positive or negative because it is the direction. Average velocity, we again revise total displacement divided by total time. If the graph is a straight line, velocity is uniform. If time is increasing, x is increasing, velocity is positive. If the slope is constant, velocity is constant. If the slope is variable, velocity is variable, and so on. Now, I would request you to attempt the other questions in your notes. And we'll now move on to the topic for today. And now again, we are still in graphs. We have done just one type of graph. We shall move on to the second type of graph now. Second graph. What is the second graph that we are supposed to do today? The second graph is known as, anyone? The second graph is known as velocity time graph. The second graph is known as velocity time graph. That is the second type of graph, velocity time graph. Velocity would be plotted on the y-axis, time would be plotted on the x-axis. Whether the particle is moving along x or y doesn't matter. We are going to plot velocity along y-axis. What will be the first type of graph? It will give us acceleration. Okay, let us now come into that. What will be, that was my first question that I wanted to ask. So note number one. And again, as I told you in the previous class, if you can't take running notes in a good handwriting, you can write whatever you understand in rough. after the class, I would be sharing this entire PPT, this entire thing with you in PDF format. Then you can make your good notes. Notes must be there. Without notes, you cannot survive. Note number 1 here. What will the slope of velocity time graph give us? Slope of VT graph, velocity time graph gives us what? dv by dt. That will be your slope, dv by dt. Yes, Karthik. The slope will be dv by dt and that will give me acceleration, not displacement. Hannah, the slope, yes, yeah, of velocity time graph will give me acceleration. But here is another twist here. Point number 2, area. Area under velocity time graph is area. See, slope means derivative. You find the derivative, you are finding the slope. dv by dt gives you a. But if you find out the area, and if you remember, area is integral of v dt. Yes, Karthik. Well done, beta. Area is integral of v dt. And area of velocity time graph gives us. What does area of velocity time graph give us? You must be knowing it. What does integral of v dt give us? It gives us the displacement of the particle. Am I clear? The area under velocity time graph gives us the displacement of the particle. It can also give us the distance traveled by the particle. We'll understand, we'll come to know after this class how do I get the displacement and how do I get the distance travel. We'll try to understand it by this class. But before going on to that, before going on to finding out these areas, let us first discuss the various type of graphs that will come to us and see how much do we understand. So we just do the first type of graph. The first type of graph would be the simplest of all, and the simplest of all these graphs would be T, V, and the particle having a VT graph like this. Particle having a VT graph like this. Now let us try to summon what do we understand from here. Let us try to summarize what we can understand from here. The first question is from me to you, is the particle moving or is the particle at rest? Is the particle moving or is the particle at rest? Everyone is saying rest. Everyone is saying rest. Don't get confused. This is velocity and time. Velocity is constant. That doesn't mean the particle is at rest. The particle is in motion. Particle is moving. Particle is moving. Number two. This is a velocity time graph, not a position time graph. Velocity is a straight line which is parallel to time axis. That means velocity is constant or it is uniform. Do we understand, Anna? Yes, Anna. Velocity is uniform. It does not change with time. It is constant. Velocity is constant. In the position time graph, if you go, when the position time graph was like this, the position was same, so it was at rest. The position was same as you can see. But here in this graph, the position is not same. Velocity is same. Am I clear? Can I have some raised hands that we understand this, sir? Velocity is constant or uniform. Okay. Now I can make point number 3. What is the slope of this graph? Is it a positive slope graph? Is it a negative slope graph? Or is it something else? What about the slope of this graph? Jai Shankar says positive, constant, positive. I'm getting all sorts of answers. The slope of this graph is zero. It is parallel to time axis. The slope is zero. Yes, Karthik, the slope is zero. You can also understand it from this point that velocity is constant. So the velocity time graph ka slope must be equal to zero. Do we understand this, everyone? Can I have some raised hands, sir? We understand this. Okay. That brings us to the fourth point. Velocity time graph ka slope is zero. What about the acceleration of this particle? What about the acceleration of this particle? What about the acceleration of this? Yes, Sainath. Velocity is constant. Slope of velocity time graph is zero. The acceleration has to be zero. Do we understand this? Acceleration is zero. Acceleration is zero. The body does not accelerate. This is a case of uniform motion. Am I clear? Am I clear? Can I have some raised hands? Can I have some support from the raised hands? Can I have some support from the raised hand? Yes. Okay. Now, look at this. If I find this area, this yellow thing that I am trying to fill it up with some material, yes. What does this area give me? What does this area give me? What does this area give me? The yellow area that I found out. What does this area give me? This area gives me, this is the area, and it gives me the displacement. Displacement is not velocity into time beta. Okay. Displacement is average velocity into time, not velocity into time. So this gives me displacement. But again remember, displacement is a vector quantity. Here talk about velocity. So it must be having a direction. It must be having a direction. The velocity that I have, what is this direction? Anyone can tell me the direction of this direction? It is positive above time axis. Velocity is a vector. It has plus or minus. Displacement is also a vector. It should also have sign plus or minus. Is the displacement positive or negative? So how do we find out whether if the area is above time axis, it must be negative? No. So it is always positive. Whether from velocity to find out displacement, we find out area. Above area is positive, below area is negative. To find out distance, we again find out area, but all areas are positive. Am I clear? Can I have some raised hands? That we have understood this, sir. Hannah has a doubt, and Hannah is asking, how can the particle move when the acceleration is zero? The particle is moving with uniform velocity, beta. It does not accelerate. Okay? The particle can have zero acceleration but still can move, isn't it? Particle can have zero acceleration but still is moving because it has a uniform velocity, beta. Please don't get confused. If you have any doubt, please ask. Maybe I am not able to clear the doubt then and there itself. Once I finish my explanation, I would be coming back to your doubt. So am I clear with this? Velocity time graph parallel to x-axis. That will take me to the second graph. That will take me to the second graph. And the second graph, second VT graph, would be like this. Would be like this. Now let us discuss what are the points that we understand from this graph. Is the particle at rest or is it moving? Is the particle at rest or is it moving? Moving. What is the direction of velocity? Positive, negative? Velocity is positive. Yes or no? Yes or no? Is the velocity constant or variable? Is the velocity constant or variable? The velocity is variable. It is changing. It is changing. Here it is different. Here it is different. Here it is different. Here it is different. Yes or no? This graph is a straight line graph. What about the slope of this graph? Positive, negative, or zero? What about the slope of this graph? Positive. Why it is positive? When time increases, velocity also increases. Am I clear? When time increases, velocity also increases. Slope is positive. Am I clear? What about the slope? Is it constant or it is variable? Is the slope constant or is the slope variable? Slope is constant. Graph is a straight line. Slope is constant. Is everyone getting my point? Shreya? Are we in the same universe that we understand these points? Now let us talk about acceleration. What about its acceleration? What about its acceleration? Acceleration is constant. Okay. What about this direction? What about this direction? It is positive because the slope is positive. Am I clear? Am I clear? Everyone, can I have some raised hands that we understand this, sir? Okay, great. Now, what I'm going to do is in the same graph, I will draw a different graph. Now I will draw the graph like this. This is my point A, and the body is moving from A to B. The blue graph I have drawn. You have to draw it separately. I'm just saving some time and drawing two graphs in one. I hope you understand this. Just saving some time. I don't have to draw it again. Now, let us talk about this blue graph and we'll write everything with blue. Point number one. Tell me what is point number one. We already have 300 messages. Point number one, is the particle moving or is the particle at rest? Remember, it's a velocity time graph. Is the particle moving? Particle is moving. We take it. Same point, doesn't change. Let us come to point number two, Deepak. What about velocity? Does the velocity become positive or is the velocity negative or is the velocity zero? Shreya is saying velocity negative. Where do we see negative here, beta? Origin is here, O is here. How is the velocity negative? It is positive. Don't worry about that. Velocity always remains positive. Unless it goes below zero, velocity is positive. Am I clear? Am I clear? Am I clear? Okay. Okay. Now let us, Deepak, it is wrong. Let us now go to point number three. First, let us discuss the point number three for the green graph. Velocity is variable, right? Velocity is variable. And the velocity is increasing. Yes or no? In the green graph, velocity is increasing or not? With time, velocity is increasing or not? Yes, the velocity is increasing better. Now let us talk about the blue graph. Is the velocity same or is the velocity constant? Yes, Jayashankar. Velocity is variable, changing, and it is decreasing. Velocity is decreasing, as you can see. At A, the velocity, and at B, the velocity. At A, the velocity is higher compared to B, so the velocity is decreasing. Am I clear with this point? Velocity is variable and the velocity is decreasing. Okay. What about the graph? Is it a straight line graph or it is not? It is a straight line graph. Jaya is getting my point. Great, Jaya. Good for you to participate. Yes, Deepak. Let us talk about point number 5. Let us talk about the slope of this graph. How is the slope of this graph? Negative. Yes, Karthik, because the velocity is decreasing. So the slope has to be negative. So I'll write negative here. The slope is negative. Clear. Great. Point number 6. Point number 6. Point number 6. Slope is constant. It's a straight line graph. You all understand this. Great. Now let us convert everything into acceleration. What about acceleration? What about acceleration? Acceleration is constant. Slope is constant, but acceleration has to be negative. Velocity is positive. Acceleration is negative, and that is why velocity is decreasing. Are you getting my point, everyone? Can I have some show of hands, raise of hands? I already have around 350 messages that we understand this, sir. Yes, sir. Clear, sir. No doubt, sir. Okay. That would take me to the last set of graphs, which I think we would discuss in the next class because the time is very less. And I also have to do the NEET wala class. So I'll stop the class here. There are other 2 graphs left. There are other 4 graphs left, in fact. How will those 4 graphs look like? Any idea, anyone? How will those other graphs look like? So I'll just give you an idea of curves. Yes, Karthik. They will look like curves. This is coming up. This is coming up in your next class. This is coming up in your next class. Parallel to y-axis, we have already done. Oh, parallel to y-axis does not make any sense because velocity cannot change without time. So the other graphs are like this. This is graph number 1. This is graph number 2. 1, 2. This is graph number 3. And this one is graph number 4. We'll be discussing these 4 graphs in the next class. And I would be very happy if you take these 4 graphs as homework and give me its analysis in the points that we have done, 5 or 6 points or 7 points or 8 points or 10 points. Give me their analysis. So what is happening here? What about velocity? What about acceleration? What about slope? Is the slope constant or variable? I hope you had a good look at these graphs. You had a good look at these graphs. So that would be your homework for the next class. If you can do it, it would be fine. If not, well, we'll discuss it in the next class anyways. That would be it. Also try questions. Also try questions from your notes. The questions on graph of velocity. We'll be discussing some questions in the next class and we'll be winding up by the graphs by the next class. If you have any doubt, beta, please come up. I'm here. Else I will, from my side, the class, yes, I will share the whiteboard, don't worry. So from my side, it is bye-bye, beta.